Okay, so today we're going to go over scatter plots and least square lines, also known as line of best fit. Now, in the previous first lesson, we talked about data tables of specifically linear relationships. Now we're going to discuss how we can find a relationship in a data table between two random variables, random x or y variables. Now, how do we do this? We want to find the scatter plot. Now, by definition, a scatter plot is a graph of a set of data pairs. Like I said, these can be random x variables or random y variables. Now let's look at the first example. So we can see here that the data is kind of spread out, but we know that there's a positive correlation. Why? Because as x increases, y increases as well. So we can put that here. Y tends to increase as x increases. This is for positive correlation. In the second example, we can see that there's a decline visually. So as x increases, y decreases. So let's put that in the box here. Y tends to decrease as x increases. And in the third graph, the data here is just completely spread out. We can't find a relationship. So if points show no obvious pattern, then we can say there is no correlation. Now when we do these scatter plots, we have to consider the outliers. An outlier is a value that is much greater or much less than most of the other values in the data set. Typically, statisticians throw out the outliers when analyzing data. So let's do the first example. We have a data table, and we don't know if this is linear or nonlinear, or if there's a positive correlation, or if there's just no correlation at all. So let's first graph. So x is 1, then y is 4, 2, 5, 3, 4, 4, 3, 5, 3, 6, 2, 7, 3, 8, 2, 9, 1, and 10, 1. So I don't know if you can see, but there we can see that there's a steady decline as x increases, and then y decreases as well. So we know that there's a negative correlation. Now, let's find the line of best fit. So here are the steps to drawing a line of best fit. So step 1, we have to draw the scatter plot. So that's what we did here. Now we sketch a line that appears to follow most closely the trend given by the data points. So let's try and draw a line here. It kind of resembles the trend that we drew here. So I'd say it starts here and ends about here. Now step 3, choose 2 points on the line and estimate the coordinates of each point. These points do not have to be the original data points. So what I do, I try to find points that are kind of are on the line. So here we can say 2, 4 is on the line and 10, 1. So let's write down these coordinates. 2, 4 and 10, 1. In step 4, write an equation of the line that passes through the 2 points from step 3. This equation is a model for the data. So if you know the equation of a slope, we subtract the y variables and divide it by the x variables. So on our calculators, we can do 4 minus 1, which is 3, divided by 2 minus 10, which is negative 8. So 3 divided by negative 8 is negative 0.375. So our slope would be negative 0.375. And we know from the previous lessons the equation of a linear relationship, which is y equals mx plus b. So our equation would be negative 0.375x plus the y-intercept, which I drew to be 5. So here is our line of best fit right here and the equation for it. Now let's do some problems. State if there appears to be a positive correlation, negative correlation, or no correlation. When there is a correlation, identify the relationship as linear or nonlinear. So before we do this, I wrote down some questions that you should consider when doing these problems. So the first question is, what patterns do you notice? Are there any clusters? Are there any outliers? Is it linear or nonlinear? So in this first question, we can see a kind of interesting pattern here. We know that's not linear because linear equations, there'd be a straight line. So we know that's nonlinear. Are there any clusters? We know that the data points are more focused here than here, so there are clusters. Are there any outliers? There's no visible outliers. It's kind of given for us that this is an exponential equation. So we know that this is a positive correlation and it's nonlinear. Now I'm not going to do all these questions. If you want to, you can pause the video and do these 6 questions and I will give you the answers at the end. Okay, so the answers to these questions are as shows. Thank you for listening in to this lesson.